everyone, and welcome to our video on the Law of Cosines application problem, which really just means we have to draw our own picture. So when we draw our own picture, just give yourself plenty of space. So I think I'll use this whole left side of the page to draw this. And then with the word problems, read them carefully and slowly and multiple times as needed. So here we've got two boaters leave the same spot at the same time. The first boater heads east. So I see a compass direction east at 4 miles per hour, while the second boater heads south 60 degrees west at 5 miles per hour. How far apart are the boaters after 2 hours? All right, so because I see compass directions, I'm going to draw a nice big northeast southwest axis, or never eat soggy waffles, or never eat sour watermelon, northeast southwest. And then we'll go from here. So it says two boaters leave the same spot at the same time. So we'll say, well, let's have them both be at the origin of this at the same time before they leave. It says the first boater, all right, let's color code. The first boater heads east at 4 miles per hour. Okay, so we'll just draw something toward the east, and we'll worry about labeling the actual length soon. Okay, so there's the first boater, first. And then the second boater heads, let's do that one in green. So the second boater heads south 60 degrees west at 5 miles per hour. Okay, so compass directions tell you start on this letter. So start on S, south, then go 60 degrees toward that letter, west. So start on the south, go 60 degrees toward the west. So that looks like it's 60 degrees. And then we'll draw in some length. That looks good too. Okay, so that's the second boater in the green. And then it's now asking how far apart are the boaters after 2 hours? All right, well, let's get those distances in then. So if this boater went 4 miles per hour for 2 hours, well, that would mean that it's 8 miles total because we could just multiply the two. So 8 miles. And then pretty much the same deal, the other one. If this boater went 5 miles per hour, so 5 miles in 1 hour, times it by 2 would be 10 miles. And then we'll find our length between the two. How far apart are they? Well, that's from this one to there. So I'm going to label it X. Okay, so there's our picture. Now, that doesn't have to be our only picture. I see a triangle. Okay, so I'm going to redraw just the triangle. Let's draw that over here now. Oop, a little off. That's okay. Okay, so we have our triangle. Okay, so a little weird looking. I think it's good enough though, because we still have, this is 10 miles. This is still 8 miles. This is our X. And then now I want to say, well, do I have any other information? Well, sure. I have the 60-degree angle right here. I'm marking it. And I know that this is also a right angle right here. So 90 and 60 would be 150. So I do have this angle, which is right here, 150. Okay, so we've got our known angle now 2 in this. Now these other two angles we don't know. Okay, so right now we don't. We could find them eventually, but right now we don't know what they are. We know this one is 150 degrees for sure. Okay, and then now that I have just a regular old triangle, I'm going to label the sides. Let's call this A, let's call this B, let's call this C. And then so we can see, again, I could try the law of sines on this. Law of sines is not going to work. So as a reminder, here's our law of sines. Often, if you have a triangle problem, the law of sines is good because it's a little faster to do, but we would not have this. If we filled in the information, we would not have a complete fraction. We would need one complete fraction on this problem to do the law of sines. So that means it does become a law of cosines problem. All right, law of cosines. Well, let's label those sides with the letters as well. So if capital A is bottom left, that means this 8 is little a, and then 10 is B, and then across from C is little c. So it looks like we need to solve for little c based on the way that I set it up with those letters. And so our equation is very much like Pythagorean's theorem. So c squared equals a squared plus b squared. but then I think minus those two letters right there. So minus, but put a 2 in, -2, and then the same two letters, AB, and then put in a cosine of the first letter, but as an angle, so cosine of C. All right, now that we've got it, we'll plug everything in. So I'm using x. I'll use x on this. You could keep it c. So x squared equals a squared, so that's 8 squared, plus b squared is 10 squared, minus 2 times a, which is still 8, times b, which is still 10, cosine of 150 degrees. And then we'll simplify this. So the letter that we want is already by itself. So we're not moving anything around. We are just doing order of operations on the right side. Okay, so as a reminder, let me scroll from a previous video or previous problems. Like this one, we were finding an angle. So that means we needed to move things around in the equation to get the angle by itself. Here, our letter's already by itself. So don't move anything, just simplify the right side. Okay, so we'll simplify that right side. 8 squared is 64. 10 squared is 100. 2 times 8 is 16. Times 10 would be 160. And then cosine of 150 degrees. And then let's continue with the order of operations. So 64 and 100 would add to be 164. And then we still have minus 160 cosine of 150 degrees. Now, cosine of 150 we can do, but I'm going to solve this as if that's an angle that's not on the unit circle and as if we couldn't use a calculator. So to solve this, we would square root both sides. Remember, the square root does the whole thing on that right side. We would automatically choose the positive in the plus minus because we're measuring a length that should be positive. And we would have x is the square root of 164 minus 160 cosine of 150 degrees. Now, one little side note as a reminder with these square roots, say it's simplified to be something like 25 minus 16. Remember, the order of operations wants to do this subtraction first, so don't square root those individually. Don't say, oh, it should be just 5 minus 4, and then that's 1. No, because really 25 minus 16 would have been 9, and then the square root of 9 is 3. So we get conflicting answers. This is the correct answer. This is the wrong answer. Okay, so the thing about square roots is they usually don't simplify very nicely. They often are just left alone. Okay, so even if you think you see, oh, I could do the square root of that number, well, probably not because it probably has some other attachment to it. So if it's or if there's multiple terms in a square root, I'd say 99% of the time, just leave it alone. Okay, which is what I'm doing here. All right, now this answer again is the answer if we could not use a calculator and this angle was something that was not on the quoted unit circle. So again, something say like 147 degrees or 176 degrees. Okay, so something that's not 30, 45, 60, 90, 120, those good ones that we use a lot. All right, instead, let me write it up here. What we're going to do is evaluate it. Evaluate the trig function. So we have 164 minus 160. Cosine of 150. Okay, so if we need the unit circle to help us still, that's fine. It's over here. And the x coordinate would be negative square root of 3 over 2. And then we would say, oh, the negative and the negative would simplify to be a positive. So that negative and that negative is a positive. And then 160 divided by 2 would be 80. So we'll change this to be the square root of 164 plus 80 square root of 3. Okay, so we have a square root in a square root. There we go. And that's our exact value answer. Okay, so exact value answer. So that's if we can't use a calculator at all, that's as far as we would want to take it. Now let's go ahead and get the decimal real quick just to see it. Okay, so square root of 164 plus 80 square root 3. And we get 17.39. Let's round to 1. 17.4. Okay, so x is about 17.4. It would be miles. There we go. Okay, one way that you can check it a little bit is so that is the right answer. One thing that I'm going to do though, just on back to the axis. So pretend like this boater went straight east. That would be 8 still. And then let's say the second boater went straight west. So that would be 10. So we can see, oh, 10 and 8 would be 18. So the maximum that they could be if they went in the complete opposite directions would be 18 miles. Well, this angle to 60 degrees is making it look pretty long still, right? So from here to here is about 9, I guess. Okay, so that's based on this decimal, and that seems to be making sense. Okay, so it's a way to double check it, which could really help in case we accidentally said, what if we forgot that the negative was there and we kept this as a minus? Then we would have gotten something that would have looked strange, and we would say, hey, maybe that's not the right answer. Okay, but that's that. So if you do have questions, please let me know. Otherwise, thanks for watching.